Hi everyone! In the previous video, we studied how to use either to provide information when an error occurs. We saw that one of the most important decisions we need to make concerns the error type. We can start with a simple type, like string, or we can use a custom enumeration if we need more precision, or consistent error messages. Today, I would like to continue working with either. In particular, I would like to focus on how to combine multiple error types together. So let's start by opening the file either exercises2, located in the package exercises.errorhandling.either. For this exercise, let's imagine that we are working on an application with a simple web form used to sign up users. For the sake of simplicity, let's say that we only need two pieces of information to create a new user record. We need a username and a country of residence. So the idea is to write some validation logic to ensure that both the username and country of residence are valid, and if not, we would like to produce a useful error message to our user. So now let's start by implementing the function validateCountry. It takes an input string, which we expect to be a 3-letter country code, and it returns an either of country error country. This means that if the input string is a valid country code, then we'll return a country object, otherwise we'll produce an error type of type country error. ValidateCountry can fail for two reasons. One, the format of the input is invalid. It must consist of 3 uppercase letters. Or 2, the country is not supported in our application. As you can see, country is an enumeration with only 4 possibilities: France, Germany, Switzerland, and United Kingdom. Maybe these are the only countries where we can provide our services. Great, so I'll let you pause the video and try to implement validateCountry. Cool, so let's start by validating if the country code, if the string, has a valid format. So we need to verify that the length of the input string must be equal to 3, and that every single letter inside it are uppercase letter. So we can say country code.forAll. Like this, it will allow us to apply a predicate for each character inside the string. So we'll say char.isLetter and char.isUpper. This way we know that within this branch, within this if statement, we know that the country code has a valid format. And then in the else branch, we know that this is invalid, so we can say invalid format, and we'll pass, what do we need, the country. So we'll pass the country code. Cool? So now we just need to implement what we need to do in this case. So now we know that the format is valid. We just need to verify if it is one of these 4 possibilities. So we could say if country code equal to FRA, if could equal, or we could say something like this, it will be very ugly. We could say if country code equal France, or I need to say country.france.code, but this would be very ugly. And the problem with this is that as soon as you start adding a new country, you may forget to update a validateCountry. You may forget to update all the logic that depends on this. This is why when I create like a custom enumeration like this, I like to also define a list that lists all the values that are possible. So you see, all is a list of countries, and there is France, Germany, Switzerland, and United Kingdom. Now it is possible that we forget to update all, and I will show you later some techniques to avoid it. But at least here it's less likely to do it, to forget to update all, because it's very close to the definition of the enumeration. So this means that here, within validateCountry, we could say country.all and try to find if any of the country has a code that is equal to country code. So we're trying to find if there is any country that has the country code that we just passed as argument. So this gives us an option of country, but we want an either country error country. But we've seen that there is a method to convert an option into an either. It's to write. So to write, And here, as a parameter of toWrite, we need to say whatever should happen in case the country code is not found. So if the country code is not found, we need to produce an error not supported. So not supported is the error that we produce in case the country code is valid, so the input has a valid format, but this country code is not supported by our application. Like this. Cool. So let's give it a try. Let's try to run the test. Yeah, it works. So as you can see, this test only checks for a couple of country code. Now, this kind of function is perfect for a round-trip based property-based test, where we could say, okay, let's generate a random country, and let's verify that the country code will be parsed correctly. So we just verify that if you pass a valid country as an input, and you try to parse it, then you get back the same country back. That's a typical good property-based test for this kind of code. Now, as I mentioned, it's a bit annoying that we had to list all the countries to create this all variable here. It would be nice if it was done out of the box by Scala. Now, it doesn't exist yet as part of the standard library, but there is third-party libraries that do this for us. One of them is called enumeratum. So I put here the dependencies to import it, and I will put some link below the video. So with enumeratum, you just need to say, you take your enumeration, and you need to add a couple of extensions, and then out of the box, they will provide lots of utilities methods. So if you really want to avoid to do it manually, I encourage you to give it a try to enumeratum. Otherwise, it's not that difficult to do it manually. It's really up to you. Okay, so now that we have a function to validate the country of residence, let's try to validate the username. So username has two requirements. It needs to be at least 5 characters long, and also we have special requirement with regard to what kind of characters are allowed within the username. So I broke down these two requirements into two functions, check username size and check username characters. They both take a username and produce an either. And as you can see, the return type, in case it's successful, is unit, meaning that unit is equivalent to void, is a special type with only one value, the empty parenthesis. So the goal is that if we call this function with a valid username, it's going to return this value, meaning that it's a way to say, yeah, it's okay, it's all good. But if it's not okay, if it's invalid, we'll get a left with an error that describes why the username is incorrect. So first, I'll let you pause the video and try to implement check username size. Okay, so here we are going to do, it's going to be fairly straightforward. We'll say username.size.length. We verify if it is bigger than or equal to 5. If it is, then we return a success. In this case, it's right of unit. And if it's not, we are going to return a left, where we'll specify the length of the username that was passed as input. Actually, we need to put it within a too small class. Yep. Let's run the test to see if it works. All good. We could have used, so it's fairly common to do an if then else for an either, like, if you respect the condition, you return right. If you don't respect the condition, you return left. That's why there is a method in the either companion object called cond. So I think it was added relatively recently, maybe Scala 2.13 or something. And so this function takes 3 parameters. The first one is the condition. And the second and third parameter is whatever happens in case the condition is successful. So first we'll have a parameter in case it's successful, and then a parameter in case it's an error. Yep, let's run the test. So again, this is really, it's the same as an if then else. It depends if you prefer to have it in one function or an if then else. It's really up to you. Now let's do the next function, check username characters. So check username characters, what we want to verify is that every single character within the username must be valid according to this function. So it must be a letter, a digit, an underscore, or a dash. So we want to verify that every single character is valid, and if it is the case, we return unit. If it is not the case, we return invalid characters, so this is a case class, and within this case class we'll specify all the characters that were invalid. Like this we can produce a useful error message. So I'll let you pause the video and give it a try. Okay, for this one, we can try to do an if then else again. So we can say, okay, something like, if all the characters are valid, so we'll say for all, we verify that they are valid. In this case, we return a right. And in case, so if in the else branch, we know that some characters are invalid, we are going to return them here. So we'll say invalid characters. And within this, we need to specify all the characters that are invalid. So we'll say username. We can do two lists to transform this into a list of characters. And then we'll filter it to select all the characters, or filter not, to filter all the characters that are invalid. So if you want, we do one pass to verify that they're all valid. If they are, we say it's OK. If they are not, we do a second pass to return the one that are invalid. Now it's a bit wasteful to, I mean, it should work, but it's a bit wasteful to do two passes. What we could do is to do it in one go. So we could say, let's copy paste this. So this will be the, this will give us a list of all invalid characters. Now a list is an enumeration, so we can do an exhaustive pattern match. And we can say, if the list is empty, it means that there is no invalid character. So if you want, it's a double negation. There is no invalid character. So if there is no invalid character, it means that it is valid. And in this branch, there are some invalid characters. So we can say invalid characters and produce a left with them, or like this. So this way it will be slightly more efficient, but also we ensure that we only, you know, it's only here. In fact, we are guaranteed that this list is non-empty, because it will be very weird to produce an invalid characters with an empty list. So let's enable the test to verify that it works. Yes, it does. Okay, so now we have two functions to verify the validity of a username. One that checks the length, while the other one focuses on the content. Now we're going to try to combine these two functions together inside the method validate username here. So validate username takes a string and produces a username object only if both validations are successful. This means that we'll need to call check username size and check username characters and somehow combine the results. So please pause the video and give it a try. Okay, so let's start by calling check username size and check username characters, because these are the two functions we're going to delegate to validate, to check the validity of a username. Cool. So both of them give us an either with something on the left and unit on the right. So we somehow need to combine them. So we could do an exhaustive pattern match, something like this. And in case, so we say, okay, if it is a failure, we return a failure. If it is a success, then basically here we don't care about it. We do another one. And again, if it's a left, it's a left. If it's a right, again, we don't care about this, it's unit. And now we know that if you want, when we are here, we know that both cases are valid. So finally, we can return a username. Now it's extremely variables, and you know, if we had to use either this way, no one will do it. But you know, we have seen this before. When you have either and you do left, 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 it means that it goes to flat map. And we know that flat map leads to for comprehension. So let's give it a try. Let's jump straight to it. So we have a username. So let's say X. I don't really know what is it yet. Y. Check username. And then we yield at the end the last thing. So here I just translated whatever we had before. So in fact, check username size, because it returns unit on the right, this value is of type unit and this value is of type unit. Unit being a single value, it means that it's completely useless. So we can use underscore to mean that we don't care about it. Really what we want to do here is to call these two functions one after another, and the only way to produce a username is if both either are right. So if both either are valid. Let's try. Yeah, it works. So once again, we can see that for comprehensions is our best friend when it comes to composing a few things sequentially. Something that I find particularly interesting is that the error types adapt automatically. If we check username size, you can see that the error type is too small, while the error type of check username characters is invalid characters. But somehow, when we combine these two isers within a for comprehension, the error type adapts to username error, which is the parent of both too small and invalid characters. So this is exactly what we want. Yet it's impressive that Scala is able to figure out the correct error type automatically. And if you're wondering how this works, check out the next video where we're going to look at a brief introduction to variance. See you soon!